This video is brought to you by mywayteaching.com.
In this part, let us study about the change of state. See, matter normally exists in three states. We all know that the three states of matter are solid, liquid, and gas. A transition from one of these states to another is called as change of state, isn't it? Change of state is nothing but change from transition from one state to the another. Two common changes of states are solid to liquid and liquid to gas. These are two are the very common changes that we see. Solid to liquid and liquid to gas. These changes can occur when the exchange of heat takes place between the substance and its surroundings. To study the change of state on heating or cooling, let us consider a very simple activity so that you'll understand it in a better way. You just take some cubes of ice in a beaker. Okay, you take one beaker and you just take some ice cubes in that beaker, which are at 0 degrees Celsius. You start heating it slowly on a constant heat source. Okay, you just heat it with a constant heat source, and you note the temperature after every minute. Continuously stir the mixture. You should stir this mixture continuously. Draw a graph between the temperature and time. Okay, draw a graph. Okay, draw a graph of temperature and time. As you can see in this particular figure, this is the graph of temperature versus time. And in this you can observe no change in the temperature so long as there is ice in the beaker. You can see even though the time is increasing, still if there is a ice in the beaker, then there is no change in the temperature. In the above process, the temperature of the system does not change even though heat is being continuously supplied. So the heat supplied is being utilized in changing the state from solid to liquid. So even though the temperature is increasing, there is no change in the, even though we are continuously giving the heat, there is no change in the temperature. So where's that heat is going then? Yes, that heat is being utilized in converting or in changing the state from solid to liquid. Okay, and this change of state from solid to liquid is called as, yes, melting. we call it as melting. And from liquid to solid, it is called as fusion. The change of state from liquid to solid is called as fusion. So it is observed that the temperature remains constant until the entire amount of the solid substance melts. That is, both solid and liquid states of the substance coexist in thermal equilibrium during the change of states from solid to liquid. So the temperature at which solid and the liquid states of the substance in thermal equilibrium with each other, that particular point we call it as melting point. Okay, that is the one of the characteristic of the substance, and it also depends on the pressure. The melting point of the substance at standard atmospheric pressure, we call it as normal melting point. Okay, the melting point of the substance at standard atmospheric pressure, we call it as normal melting point. Okay, you just do one more very simple activity. Take a slab of ice. Okay, you take a slab of ice and a metallic wire and fix two blocks, as you can see in this figure, a slab of ice and a metallic blocks. Okay, using a metallic wire, these two blocks are fixed. Say they are 5 kg each at its ends. Then put the wire over the slab, as it is shown in this figure. You this wire over the slab, and you observe that the wire passes through the ice slab. This happens due to the fact that just below the wire, ice melts at low temperature due to increase in pressure below the wire. When the wire has passed, the water above the wire freezes again. Thus, the wire passes through the slab and the slab does not split. This phenomena of refreezing is called as regulation. Okay, this phenomena of refreezing, we call it as regulation. Skating is possible on snow due to the formation of water below the skates. Water is formed due to increase in pressure and it acts as a lubricant. After the whole of ice gets converted into water, as we continue further heating, we shall see that the temperature begins to rise because that change of state has taken place from solid to liquid. Now, whatever the heat that we provide, it is utilized to increase the temperature. So the temperature keeps on rising till it reaches 100 degrees Celsius, when it again becomes steady. So the heat supplied is now being utilized to change the water from liquid state to vapor or gaseous state. Okay. First, the heat what we were providing, that was used to change its state from solid to liquid. Then it starts increasing its temperature up to 100 degrees Celsius. when it reaches that boiling point, again the temperature, no, the heat that we provide is utilized to change that state from liquid to vapor state. So that change of state from liquid to vapor, we call it as vaporization. Okay, the change of state from liquid to vapor, we call it as vaporization. Okay, it is observed that the temperature remains constant until the entire amount of the liquid is converted to vapor, which means both liquid and vapor states of the substance coexist in thermal equilibrium during the change of state from liquid to vapor. So, the temperature at which the liquid and vapor states of the substance coexist, we call that point as boiling point. Okay, so you just consider one more very simple activity. Take a round bottom flask, and more than half of that flask should be filled with water. Okay, and keep it over a burner and fix a thermometer and a steam outlet through the cork of the flask, as you can see in this particular figure. So you can see in this particular figure, the water flask, it is filled, more than half of it it's filled with water. As water gets heated in the flask, note that first that the air which was dissolved in water will come out as in the form of bubbles, as small bubbles. So later bubbles of steam will form at the bottom, but as they rise to the cooler water near the top, they condense and again they disappear. Finally, as the temperature of the entire mass of the water it reaches 100 degrees Celsius, bubbles of steam it reach the surface and boiling is said to occur. So the steam in the flask may not be visible, but as it comes out of the flask, it condenses as tiny droplets of water. It will give a very foggy appearance. If the steam outlet is closed for few seconds, you just close that steam outlet for very few seconds, then the due to the increase in pressure in the flask, you notice that the boiling stops. More heat would be required to raise the temperature before boiling begins again. Thus the boiling point increases with increase in pressure. So now let us remove the burner and allow water to cool to about 80 degrees Celsius, and even remove the thermometer and a steam outlet. Close the flask with the airtight cork. Keep the flask turned upside down on the stand. You just reverse it and pour ice cold water on the flask. Water vapors in the flask condense, reducing the pressure on the water surface inside the flask, and even the water begins to boil again, now at a lower temperature. So thus the boiling point it decreases with decrease in pressure. With increase in pressure, the boiling point also increases. When you decrease the pressure, the boiling point automatically decreases. So this explains why cooking is difficult on hills, because at high altitudes atmospheric pressure is lower, reducing the boiling point of water as compared to that at sea level. On the other hand, we can say boiling point is increased inside a pressure cooker by increasing the pressure. Hence, cooking is faster. The boiling point of a substance at standard atmospheric pressure is called as a normal boiling point. Okay? The boiling point of a substance at standard atmospheric pressure, we call it as a normal boiling point. However, all substances do not pass through the three states, which means solid, liquid, gas. There are certain substances which normally pass from solid to the vapor state directly and vice versa. It is not required that all the substances should pass this state only, means solid to liquid, then liquid to gas. So there are some substances which directly change their state from solid to gas and vice versa. So the change from solid to vapor state without passing through this liquid state, we call that process as sublimation. Okay, and the substance is called as sublime. Dry ice, that is solid CO2, sublimes also iodine. So during this sublimation process, both solid and vapor states of a substance coexist in thermal equilibrium. Example for this sublimation, it takes place in case of iodine and even in case of dry ice.